Alright guys, so we're going to talk about absolute value inequalities. So we've talked about solving inequalities, we've talked about solving absolute values, so kind of, smushing some of those ideas together. So we know the absolute value is defined as a distance from zero, and then when we're talking about an inequality, that means that we have many values that could be used as our answers. So if I say like the absolute value of b is greater than or equal to 3, or sorry, just greater than 3, it tells us b is somewhere greater than 3, but not equal. That's 3 units from 0, right? So think about that as long as we're further than 3 units from 0, that's an answer. So all of those numbers that are past -3 and all of those numbers that are past positive 3. And so we would be less than -3, or we'd be greater than 3, because we can't be less than 3 and greater than less than -3 and greater than 3. That doesn't make sense. So how do we write that? How do we write two inequalities in interval notation? So since it's heading to the left forever, we're going to get that negative infinity, and then the -3 would be our the end of that, and then parentheses since it's not equal to, always parentheses on infinity. And then on the other one here, so it starts at 3 and then goes to the right forever, so the infinity. And then how do we write or? So what we call, with interval notation, is called the union. So union is basically like the or, saying that an answer from either group would be okay. So we use this upside down u, or no, upside down u, the u for that, for union. There's another symbol called intersection, where it has to be like a member from both groups in order to be an answer. So we don't see that much with these problems. So union and intersection. So that kind of thing about the answers, right? So if our answer was 4, then that would be true, because 4 is further than 3 from 0. And then if the answer was -5, that would also be true. Like things that you could plug into here, like we could plug 4 to here, that would work. We could also plug -5 into here, and that would work and make that true. Here it's saying like 0.3 would not be a viable solution. Like if we plug 0.3 in there, it would not be greater than 3 units away from 0. So all these numbers in here, including -3 and 3, would not be viable solutions. Okay, the other side of that is, so here we saw a greater than, here is a less than. So it says that C is, the absolute value of C is less than or equal to 2. Okay, so that C is somewhere 2 units or less away from 0. So it can be anything that's in this space, anything that's in this space, and those would all be solutions. So if we plugged in 1, 1 would work there, right? If we plugged in -1, it would also work there. But something like if we plugged in 5 or -5, those would not be answers, right? And we could plug in 2 or -2 because of the equal sign. So interval notation for this. So starting at -2, ending at 2. So always go left, right, and because it's equal to, closed circle, we get the brackets. So just notice the difference between the or problems, the way they're written in interval notation. So we need 2 intervals because we have 2 arrows, because we can't be both less than -3 and greater than 3. Whereas here with the and problem, okay, where it's bigger than -2 and it's less than 2, right? There's lots of numbers that are bigger than -2 and less than 2. So we just have one interval there. Any of those numbers would work. So here we're going to describe all the values within a distance of 3 from the number -1. So what this is telling us to do is start at -1. I'm going to find all the numbers that are 3 away from that. So if I go 1, 2, 3, there's 1. All right, so all of these numbers are within 3 of -1. Or if I go 1, 2, 3 the other direction, so all of these numbers are within 3 of -1. So how do we write that as an inequality that you would solve? So once the absolute value of x minus whatever that center location is, so that's the the -1 there. So what number are we moving away from? So -1. So even though it says minus, make sure you put minus -1 in there. And then how far from that number can we be? So they're saying, be 3 away from it. So because it is x minus -1, I'm going to go ahead and change that to x plus 1, and then less than or equal to 3. So just notice that, there's that number inside of the problem that's changing signs. That's something we would have seen a lot of last year. And you guys that were with me, we would talk about h being a liar. We saw that stuff inside the parentheses always change signs on us. So I'm kind of seeing it here with stuff that's inside the absolute value bars changing signs on us. And so how do we solve this? All right, we haven't done any solving yet. So remember the two big ideas with one with absolute values was that we need to split the problem into two. So that's the first thing. So we're going to split the problem into two. So I write x plus 1 is less than or equal to 3. Okay. And then the other one, so as we do x plus 1, and then we're going to say, well, remember that part on the right side should switch signs. Well, as we switch signs, we also have to switch the symbol around. So this is something we did with the absolute, with the inequalities, right? When we divided by a negative number. So here we're kind of seeing that, imagine if a -1 switched over here, that we'd have to flip that symbol around. So you have to remember that when you write that second inequality, that you flip the symbol and switch the sign. So it's usually, this is where people usually make mistakes. And again, remember this part doesn't change. X plus 1 stay the same. It's this. One time it stayed exactly the way it was. Next time both of these switch. And of course that's easy to solve. We'll just subtract 1 from both sides. And we see that x is less than or equal to 2, and x is greater than or equal to -4, which we already said, right? There's our -4, there's our 2. So how do we write our answer? Is this going to be an OR problem, or is this an AND problem? Well, the graph kind of tells us one thing, right? We see that it's all of these numbers between here, which is what the AND problem looked like, right? When it was an OR problem, that's when the arrows went off in different directions. But here the arrows head towards each other and then join in the middle. Okay, so we can say that. We can see that the answer is that way. So if you have it graphed, then you can kind of look at it. The other way to do it is to ask yourself, can a number be less than 2? And you always say and. Can a number be less than 2 and bigger than -4? Are there numbers that are less than 2 and bigger than -4? And of course, the answer there is yes. There are numbers that are less than 2 and bigger than -4. So you would then need to rewrite it as, so we put the smaller number on the left. So x -4 is less than or equal to x. So essentially I'm taking this and flipping it around. Okay, so x, and then we're going to take the other part, which is the x is less than 2, or less than or equal to 2. Okay, so your inequality should look like this. Since it is an and, it needs to be a compound inequality like this. And that means our interval notation will look like this. So -4, since it's a bracket, it's because it's equal to. Okay. Remember the brackets are here because it's equal to, not because it's an and problem. If the problem had been different, if we had solved it and it come out this way, let's just imagine the numbers have been flipped. So we'd say, can a number be less than -4 and bigger than 2, right? Are there any numbers that are less than -4 and bigger than 2? No. And so all we'd have to do at that point would be say, well, this is an OR problem. And then we'd say that x is less than -4, which means from -4, or from -infinity to 4, and then union, and then from x is also bigger than 2, so 2, oops, that should be a bracket. So if it's an OR, that's why it would have been an OR, because it can't be less than this number and bigger than that number. That does not make sense. So then you would write it like that. But of course that's not what it said. So okay. This, your answer will look like this. You're gonna just have to write that out. It'll give you a problem like this, and you'll need to write the inequality. You don't need to do the rest of it. So let's go ahead and solve these inequalities, right? If you probably want to go ahead and graph them on the solution on the number line and then write your interval notation just as helpful. So let's go ahead and do the splitting. So Mary, you write it pretty much the way it is. Make sure you get rid of those bars though. So x plus 3 is less than 5. And the next one is going to be x plus 3, so left side stays the same. But then we switch the symbol and switch the sign. So don't forget that. Once you've got it broken, easy peasy solve. So x is less than 2. X is greater than negative 8. So we stop and ask, can x be less than 2 and x be greater than negative 8? Are there numbers that are less than 2 but also bigger than negative 8? Of course there are, like 0. So rewrite it. So take the smaller of the two, and it goes on the left. The x should be in the middle. Then the bigger of the two should be on the right. Notice how it's opening towards the 2 on this one, so that should stay towards the 2. And it's opening towards the x on this one, so this one should open towards the x. No bars, since they're not equal to. If you needed to graph it, don't worry about doing a whole bunch of lines between that. It's not a big deal. Just sketch it out real quick. 0 would be there-ish. We'd have an open circle, x is bigger than negative 8, so it would be this way, right? X is less than 2, so it would be this way. But we already said that, right? It should be the numbers between them. Plenty of numbers between those two numbers. So this is an and, we get one interval. And since those open circles, we get parentheses. Okay. All right. Pretty much the same thing here. I'm going to break it first. 5m minus 1 greater than or equal to 19. Then we flip it. 5m minus 1, left side stays the same. Now we flip the symbol around and flip the number and solve. So 5m is greater than or equal to 20. 5m is less than or equal to negative 18. So m is greater than or equal to 4. And 18 divided by 5 doesn't happen, does not reduce. Okay. So once we're done solving, we stop and ask ourselves, all right, so m is greater than 4. So we're going to have a number that's bigger than 4, but also less than 18/5. Any numbers bigger than 4 that are less than this number? There are not. So we'd write or between them. If we had to graph this, I would take that in 18/5, which is like, what, 3 and 3.6. That'd be 0. And then 4. So we get closed circles on both. It's equal to, it'd be m is less than 18/5. M is greater than 4. And then I'll leave you guys to write that in the Edpuzzle what the interval notation is. But all right, last thing. So just like the absolute value equations, you have to isolate first before you can solve it. Okay, so that's part of being an absolute value equation. So looking at this, left side here, that this is outside the bars, so it has to go away before we can deal with that. And just like we talked about in that lesson, if that hadn't been here, we can't have anything that's negative over here. That would just tell you right there it's unsolvable. So, but because that is there, it's gonna, as we get rid of it, it'll fix things. So I'm gonna divide by -2, both sides. course, negative 6 and negative 2 give us 3. And then, since we divided by negative, it's going to flip my inequality around. Then we go to the splitting. So k minus 4 is greater than or equal to 3. And then k minus 4 is less than or equal to 3, negative 3. And then, of course, we'll just add 4 to both sides. K is greater than or equal to 7. K is less than or equal to 1. So we've solved. So k is greater than 7. So I have a number bigger than 7, but is also less than 1. Any numbers bigger than 7 that are less than 1? Of course not. So this is an OR. So I have a 1 over here. I have a 7 over here. It says that we are less than or equal to 1. So close circle, arrow to the left. Greater than or equal to 7, close circle, arrow to the right. And then, since we have two inequalities, or 2 arrows, left forever is negative infinity. Let me stop at 1 exactly. And then starting at 7 exactly, and then going right forever. And good old union, since we have those 2. All right. So a pretty easy lesson. I want you guys to add a couple problems onto the assignment. So the 15 to 23, and then I want you guys to do 24 through 27. But on those, I just want you to write the inequality. You don't need to solve them. So they're going to be just, okay, easy peasy. See you guys.